Next, I'm going to solve our same ODE using the method of undetermined coefficients. So find the general solution to dy dx is minus 3 times y minus 20 using the method of undetermined coefficients. Now, usually this method is used for a higher order ODE, higher than order 1, but it still works for order 1. So the first thing to recognize is that this is a linear, non-homogeneous ODE with constant coefficients. So let's write it that way. dy dx plus 3y is equal to 60 is writing this as a linear ODE in standard form. Okay? So the general solution is y equals yh plus yp, okay? Where yh is the general solution to the associated homogeneous equation if I set the right-hand side to 0, to dy dx plus 3y equals 0, and yp is a particular solution to the non-homogeneous ODE. Okay? So I got to find more than 38 trillion solutions to this one. I've got to find an infinite number of solutions to this one and just one measly solution to that one. Okay. All right. And that's how I find the general solution. Okay. So, okay. Let's think I'll erase this. All right, so how do we solve this one? And so you notice I'm reviewing a lot of sets 9 through 12. I'm not reviewing it really thoroughly, but at least I'm doing the bits of all of them. How do I solve this thing? How do I solve dy dx plus 3y equals 0? By these methods, there are lots of ways, but we try y equals e to the rx. So y prime is r e to the rx. We get the characteristic equation. This becomes r e to the rx plus 3 e to the rx equals 0, or r plus 3 times e to the rx equals 0. Or r plus 3 is 0, right? So remember, we get the characteristic equation for an equation like this by every derivative gives you a factor of r. No derivatives, no factors of r, okay? This is often written as, y prime plus 3y equals 0, or maybe dy plus 3y equals 0, or maybe even d plus 3y equals 0. Those are all the same equation, and each one of them gives you r plus 3y equals 0 is the characteristic equation. For the ODE. Okay. Sometimes it'll be quadratic. If it was a second order ODE, it will be a quadratic equation for R. If it's a degree 7 ODE with a 7th order, I get a degree 7 polynomial for R's. Be hard to factor, but maybe it's given to you in factored form because it started with the D's. Remember here, the D is the d dx. D is an operator, d dx, a derivative. R is just a number. They're not the same thing, but they're pretty close. All right, so one of the solution is R1 equals minus 3 is in fact the only solution to this linear equation. So y is e to the minus 3x is a solution. And the constant times that, and in y, h is c e to the minus 3x is the general solution to this linear homogeneous ODE. So let's just we get y is yh plus yp, and we found that yh is c e to the minus 3x. Okay, so we want to find yp now. What was it? Dy dx plus 3y equals 60, right? Well, this has all the things we need to use a method of undetermined coefficients. The left-hand side is, it has constant coefficients. The right-hand side involves just sines, cosines, exponentials, polynomials, and products of those. Maybe it doesn't look like it. That is a polynomial of degree 0, 60, right? So, in other words, give me yp is just a. This is the general solution right, to the simplest linear homogeneous ODE with constant coefficients. Okay. That has y equals 60 as a solution. This is the rule 1 thing. And what is that ODE? It's y prime equals 0. Y prime equals 0 has a solution y. First, it's a linear homogeneous ODE with constant coefficients. Homogeneous, 0 on the right-hand side. This has general solution y as a constant. Okay, could be that constant, could be 60, right? Now, does rule 2 apply? Does rule 2 apply? Is A solution to that guy? No. So rule 2 does not apply. I mean, I'm going through that sheet, and I certainly hope you have studied that PDF that's on the website with the rule 1 and the rule 2. So what we do is now, that's just the form of yp. We plug that into the ODE. Yp prime is 0. So what we get is that 0 plus 3a is 60. So a is 60 over 3. A is 20. So that means that yp is 20. Okay? And by the way, I went through this, but remember, I just got to find the solution. So actually, if I was going to do this, yp equals 20, you could look at the original thing. Give me a solution to this. Give me one solution to this ODE. Yeah, sure, there's the equilibrium solution. Y equals 20 is a solution, right? Because if I differentiate a constant, I get 0 on the left. Minus 3 times 20 minus 20 is minus 3 times 0, which is 0. Good. So, right? So remember, this method is just a way to kind of help you to find a particular solution. But if you find a particular solution by any way that's not cheating, right? You can't ask your friend what it is. You can't ask, Google what the solution to that particular differential equation is. You can go look at my websites of how you use this method, but, right? Okay, all right, we got it. So that means that the general solution is yh plus yp, or in other words, y is c. That doesn't look very nice. The general solution is yh plus yp. Yh is c e to the minus 3x plus 20. Okay, so now this is the 17th time, whatever, that we've obtained this solution. All right? Okay, bye.